Hi, everybody. There's been some requests that I go over the lab for tonight. So let me go over how to do that lab real quickly. So what I have up on my screen right now is MolView. I'll come back to that in just a moment. So I'm going to go ahead and open up. I have to jump around a little bit. So this is the lab itself. So remember that the whole idea is that we're going to be drawing Lewis dot structures, and we're going to be drawing the actual structural formula, so the shape of the molecule. In order to draw the shape of the molecule, we have to use, see if I can draw on this, we have to use those shapes right there. So if the part of the molecule is flat and it's right in the plane, like if you were drawing on a piece of paper, if it was flat and right in the plane of the computer screen, you can use a solid line like this. Okay, if it is coming out behind the computer screen, then you would use this dotted line here. And if it's coming out toward you, you would use this triangle here. So let me give you the examples that are stated here. Water is a flat molecule, which basically means that the oxygen and the two hydrogens can be rotated so that they are just right up against your computer screen and completely flat. No part of the molecule comes out and no part of the molecule goes in. However, you can rotate it. So you could rotate that molecule so that one of the hydrogen points out and one of the hydrogen points back. But the way it's shown right now, it's just everything is flat on the screen. So let's try it. Let's look at the NH3 that's next to it. In this case, they're showing that two of the H's are flat with the screen and one of the H's is coming out toward me. In the example of methane or carbon tetrahydride, it shows me that one of the hydrogens is coming out toward me, one of the hydrogens is pointing back through the screen, and two of the hydrogens are flat with the computer screen here. So we're going to use that bit of symbolism in order to be able to draw what we need to draw for this lab. So remember that you're going to rotate the molecule periodically so that you can get a full 3D view of it. It says go to molview.org. I already did that on my other page. In the upper left-hand corner, you're going to type in the molecular name. Sometimes MolView is glitchy, so if weird things are happening, try it again. Don't get frustrated. If it's not working, try a different molecule and see if you can get it to work. And then number 3 says draw using the 3D diagram symbols above. So that's these things that we just went over. Okay, I'm going to switch pages. And now it has very specific instructions for what to do with each section. So for section number 1, I'm going to switch to the next page here. And notice this is section number 1, this is section number 1, and this is section number 1. So it told me to research how to draw H2O, NH3, and CH4. So I'm going to go ahead and open up, and I'm going to look at H2O first. So in the search bar, I'm going to type in, I wonder if it says right here. I wonder if it'll let me write H2O. No, it didn't let me write H2O. Does it know what I wrote? Almost. That's not what I expected it to do. I want my computer keyboard. Okay, so back, we need H. I need a 2. This is more complicated than I thought it was going to be. Sorry about that. And then I need an O. And so I'm going to hit return. And there's water. And it's pulled up a diagram of, oops, I can't draw on that, a diagram of water. And importantly, it's pulled up the 3D molecule of water on the right side. I'm going to rotate that molecule of water, which is trickier to do. I'm using my screen instead of my trackpad. Give me a second. I'm going to use my trackpad to try to rotate water around. So now do you see that I can rotate water in all kinds of different directions? So I'm going to rotate water, and I can see that if I draw it like this, then all 3 things are in the same plane. It's like it's flat, and water is a flat molecule. So I'm going to go back over to my drawing. Here's my drawing, and I'm going to pinch it bigger so that I have more space to draw it. And I know that oxygen, and then it bonds with a hydrogen, and it bonds with a hydrogen. And I'm going to do my Lewis diagram, so I know that oxygen has 6 electrons, valence electrons, and each hydrogen has 2 valence electrons. So I have 8 electrons that I can distribute across this diagram. So there are 2 in the bond between oxygen and the first hydrogen. There are 2 in the bond between the oxygen and the second hydrogen. And then, oops, that's not very neat. Then there are my other 4 electrons. So total, I have 8 electrons, and I have correctly drawn my Lewis diagram. Now in the next column, it asks for the number of bonded pairs. Well, we have a pair. Let's see if I can change colors here. What's a good color? Let's try blue. So we have a bonded pair right here, and we have a bonded pair right here. So we say the number of bonded pairs is 2, and then the L stands for the number of lone pairs. That's 1 pair there and 1 pair there. So we have 2 lone pairs. So then the next question asks for what type of molecule this is. This is where you might want to go back to your notes and look that up. So remember that A is the center molecule, which in this case is oxygen. B is the number of bonded pairs. So we have 2 bonded pairs. These lines here and this line here, those are the bonded pairs. And then the E, my picture is in the way here. Let's see if I can make that go away. Then the E is the number of unbonded pairs or lone pairs, and we put a 2 there. The last thing that we need to do is, molecular shape and bond angle. So then that comes from the notes that we took today. And so we learned that that shape where it's actually water was the example. We learned that that shape is called bent. And then the bond angle, and I'm trying to remember it off the top of my head. I should have had it pulled up. I think it was 104.5, but it's in your notes. You should look at it and confirm my memory. I think it's 104.5, but don't quote me on that. All right, and then the last thing that we do is we draw a 3D sketch of the model. And then in this case, the 3D sketch of the model is actually very, very similar to the Lewis dot sketch because this is a flat molecule, because it's not really 3-dimensional. So I'm going to have my oxygen. I get to draw solid lines because they're in the plane. And this is my hydrogens. And that is my 3D sketch of the model. And I'm done with that. So now let's try one that's a little bit trickier. So let's go back. Let's go back to NH3. So I'm going to draw the Lewis dot. So I'm going to draw N. And here are my hydrogens. I wish I didn't have to be writing on a bouncy screen like this. All right, and I'm going to count my valence electrons. Nitrogen has 5 valence electrons, and each hydrogen brings 1 to the table. So I have a total of 8 valence electrons. Right now, there are 6 in the 3 bonds, so that means that I have an unpaired share of electrons right above the nitrogen. So over here, for the number of bonded pairs, I have 3 bonded pairs. I'm going to switch colors again so that you can see them clearly. There's 1 there, there's 1 there, and there's 1 there. Those are the 3 bonded. And then the lone pairs, there is 1 lone pair. When we write it out, A stands for the center molecule, which in this case is nitrogen. B stands for the number of bonded pairs, so there are 3. And E stands for the number of lone pairs, and there is 1, that's a 1 lone pair of electrons. All right, let's scooch it over. The next column asks for molecular shape. So that shape, and you look in your notes to know this, is trigonal. No, not bipyramidal, sorry. Pyramidal. And again, I don't remember off the top of my head what the angle is. It's like 107, maybe 107. That's a question mark. So don't copy that right there. But now here's where we need to use our special tools for drawing a 3-dimensional element. So I'm going to go back to MolView. Let me see if I can pull that up. And I'm going to type in MolView. I'm going to type in NH3. And there it is. And I'm going to hit enter, and it pulls up NH3. Now I'm going to blow up NH3, and what I see as I rotate NH3 around is that the nitrogen is kind of sticks out, and then the 3 hydrogens stick down. So I need to be able to draw that. So I'm going to rotate the molecule in a way that makes most sense to me, and you can do it however you want. So how about I do this? I'm going to rotate it like this. Can you see that the furthest right hydrogen is actually sticking out? It's sticking out toward me. So I'm going to show that with a triangle. a black triangle coming out toward me. And then the other two are in the same plane. I could set them on a piece of paper and they wouldn't poke through the back of the paper or stick out through the paper. So those are in the same plane. So I can draw this many different ways. This is the way I choose to draw this one. So I'm going to go back to my drawing program and I'm going to put the N was like this, and one hydrogen was like that, and one hydrogen was like that, and the third hydrogen was sticking out. Boy, is this hard to do, sorry. If I could have just folded over my thing and didn't have to have my screen up in the air, I could have done it better. But that's my three-dimensional diagram of ammonia or nitrogen trihydride. That's my three-dimensional. I'll do one more just so you feel good about it. Actually, I'm running a little bit low on time, so I don't think I can do one more. Let's just really quickly look at methane together. Give me a second. So I'm going to type in CH4. Now, this is one that I know is a little glitchy. Yep, and sure enough, it said it doesn't work. Let's try it again. Come on, CH4. We can make that work. So CH4. Let's try it. Nothing. So let's try the other name of it is methane. So let's try methane. Let's see if methane will open up. Okay, so it's still not working great, but so over on the left, why is it just a C? That doesn't make any sense. It's supposed to be CH4. But here is CH4, and I can rotate it around and make it do different things. So rotating CH4. So I'm going to try to draw CH4 in the way that makes the most sense for my art skills. So let's see. I'm going to draw... I don't know. I have to pick the way that I want to draw it. It doesn't matter. I know. I'm going to draw, let's see. Try to draw it. It's a little bit tricky. I'm going to try to draw it like that. So what I see is there's one that's in the back. So that one I'm going to draw a dotted line to. And there's one that's sticking out toward me. And I'm going to draw a triangle on that one. And then the other three atoms, I could lay them on a piece of paper. They're all flat. So let me show you how I would draw methane. Give me a second to get it pulled up. So methane over here would be, there's a carbon. And then, actually, I better look at the diagram one more time. So it's off. They're off on two angles, and those will get to be straight lines because they're in the same plane. So H and H. And then the one in the back is a dotted line because it goes behind. And then there's one that sticks out toward me, and so I use a triangle. I'm so sorry, my handwriting is so messy. All right, ladies and gentlemen, I need to end there. Hopefully that was helpful to get you started. I'll go ahead and figure out how to stop now.